ViryaOS, that's a proposal for a new Zen project sub-project. So to understand what ViryaOS is, I would like to start by explaining what are the problems that we would like to address with Virya, because it's more than one. So the first problem that we're trying to address is that multi-domain builds and deployments are today very difficult. So many of you come maybe from a server or data center background where you're used to having Zen and DOM0, maybe driver domains, and then all the application, all the VMs are deployed dynamically by the user. You don't really know how many will be deployed by whom exactly. But in embedded and automotive, in embedded and IoT, the use case is quite different. So often the user knows exactly how many VMs is going to run. The number is usually quite small. Maybe it's just 2 VMs total. Could be 3, could be 4, maybe 6. Now you might think, well, first of all, when I say user, I mean a system integrator. Right? Our user here are the people that build drones or IoT things, right? Not really end customers. So you might think that for our users that might be easier, right? Because they know exactly how many VMs they need. It might be easier to configure than a server-like system where it's all dynamic. But actually no, because now you don't have to just build Zen and DOM0 and any of the driver domains you want. But you also need to build all of your guest VMs and pull them all together in a single final image. So you don't have one build system with Zen and DOM0, you have at least 2 or 3, one for each VM, which are going to be very different. One of them might be an Android VM, right? You also need to pull together all these output images into a final ready-to-use image. On ARM also, device assignment tend to be static. So it's not configured at runtime. You need to edit the device tree for DOM0 and produce a device tree node for each of the guests that you want to assign a device to. So there is a certain amount of configuration that need to be done beforehand, again, at build time. Today, there is just not a simple solution to all these problems. And people tend to have ad hoc scripts to solve these issues. Now, well, we know that the track record of upgrading software in IoT is pretty terrible, but we're trying to improve that. So as our users are putting together these images, you also need to plan for software upgrades. So they need to find a way to upgrade Zen, DOM0, or driver domains, and any of the other VMs. So if that is not clear, what I'm trying to say is that it's a lot of work. It's a lot of work that is often not very, it's very repeatable. Like every time you have a new project, you tend to be able to reuse very little of what you've done before, and you need to write your own script and your own configuration again from scratch by hand. It's not fun. And if you're convinced that it's bad, now you start to think about disaggregation, right? So maybe for security, you want to do manager branch, you want to do a network driver domains, you want to have a TPM manager, and the problem becomes exponentially worse. As I mentioned, today we have, a bunch of companies have their own little scripts that are not really ideal. Also, they only target one board, the one that for their use case, one stack, the software stack they need for the use case, and they're very much narrowed down to this specific use case, and they are very hard to reuse for other use cases, for other boards, for other builds. So this is the first problem that we're trying to solve, to help people to put together a Xen-based system for embedded with a predetermined number of VMs. Problem number 2, Docker in embedded and IoT. Why, and also, do user want it? Yes, user want Docker and IoT. Why is that? Well, if you are one of our users, and again, when I say user, I really mean a system integrator, an IoT device builder, you have at least a couple of problems to solve, in addition to the one I mentioned before. you're likely to have a number of dynamic applications you need to deploy to the IoT device. You need to deploy them dynamically, you need to deploy them independently, and also manage their life cycle independently. So you probably, as a user, already use Docker for your own builds, for your own test infrastructure, so now you have a sudden brilliant idea. Why don't I use Docker to solve these problems? Docker gives you the way to build your apps, the way to deploy your apps independently and to manage their life cycle. Looks like, well, it's a done deal, right? And well, under a certain point of view, it kind of is. So there are very good reasons for wanting Docker on your IoT device to solve this problem. It's just that special care and attention need to be taken. Specifically, again, the two problems, packaging and running. On the Docker side, they're covered by two different specifications and two different sides of the Docker project, which is, well, the OCI, Open Container Initiative, image specification, and the OCI, so again, Open Container Initiative runtime specifications. Those are two different specifications maintained by the Linux Foundation to package container applications and also to provide an environment for running these applications. So you can use Docker to download your apps from the Docker registry, from the Docker hub, and up to here is all about packaging. It's all about the new cloud RPM format, let's call it that way. And then once you have it on host, then it's about running it. And the default way to run the application with Docker is by using Linux namespaces. Linux namespaces like the file system namespace, a networking namespace, and so on. Now, so for the people, the one of you that have already attended my talk last year, I talked at length about these issues, so I'm going to give you the shortened version. But Linux namespace, so the packaging format is very widely applicable to a wide range of use cases, including IoT and all the way to supercomputers. The runtime environment based on Linux namespaces is good for some use cases, is not as good for some other use cases. There are some compromises that need to be made, so it might not suit all your requirements. And I'm going to start with the one I talked the most about last year, that is security. So the main problem with Linux namespaces is the shared kernel. So obviously all these apps are running on a single Linux kernel, and as you know, the Linux kernel interface to application is very large. It's difficult to secure. There are a number of privilege escalations being discovered for every Linux release. There are technologies to restrict this interface, but they're actually very hard to use and even harder to use without knowledge of the application running inside or at scale. That means actually configure them correctly, it is actually a daunting task. And there are SC Linux and setcomp mainly. So that's problem number one with Linux namespaces. As a matter of fact, what people do in the cloud is they run containers of the same owner inside a single VM, but they never mix containers of different owners on the same VM, because one malicious container could take over the whole thing relatively easily. So this is one issue that you might have on IoT, but there are also other issues new, specific to embedded and IoT environments. Specifically, mixed criticality is, I think, the biggest one. So the use case for virtualization in embedded and IoT is to be able to run applications that are of different criticality levels on the same SoC. What do I mean by that? You typically have a very, very critical application, the kind of critical that if it goes down, your company loses money immediately, or lives are at risk, or at the very least your job is at risk. And then alongside that application, there is another app which is not as critical. If it crashes, it's bad, but who cares, right? the user is going to click that button and it's going to restart. Okay. Typically, a typical example is an Android-based UI. It's large. There's a lot of lines of code in there. It's not very secure, and it's likely to crash. And it's run alongside something incredibly important, such as software connected to a medical device. I'm not saying the software that controls the medical device, but the one gathering the input data. And maybe there is some little parts that needs to be done. And then the Android UI is in charge of displaying the results. So you definitely don't want to lose, even for a little bit, the parsing of those sensor data. But if the rendering of it crashes for a little bit, it's not that big of a deal. So there are a number of use cases like this, where the UI is large, and if it crashes, it's not that important. But the application running alongside is super, super critical. Now, if you think about containers and Linux namespaces, can you imagine running these two apps on the same kernel? When Android crashes, you are pretty certain the whole thing is going to go down. And this is what you really have to avoid. So you can't really use containers. When I mean container in this context, I mean the runtime environment of containers, so Linux namespaces. You cannot really use Linux namespaces to solve mixed criticality problems. The other issues are resource limits. So as you can imagine, if you have a very critical app, you want to make sure it has always all the RAM it needs, all the CPU time it needs. No uncertainty can be about it, right? It has to be like 100% of the CPU time, so 2 GB of RAM, they need to be fully dedicated. It's much harder to configure such a system with Linux namespaces. If not impossible. As a matter of fact, even as of today, it's discouraged the deployment of things like databases on Linux namespaces. Real time. Again, in an example I gave before, so the sensor parsing application, the critical app, is likely to have some form of real-time requirements. It cannot really miss deadlines. It's not impossible, but very hard to configure a system like that with Linux namespaces. And finally, certification. Well, it is actually quite impossible to configure a system, a certified system with Linux namespaces, because Linux cannot be certified. I mean, it's not believed to be certifiable as of today. So these are the reasons why Linux namespaces are not really well suited for embedded environment. However, as I showed before, containers are not just Linux namespaces. There are packaging format and the runtime environment. And if you go back to the packaging format, that's great and can be used for everything, including your very critical apps. You just don't want to run this app with Linux namespaces. Today, Docker. So last year, I've been told I was pretty harsh with Docker, and I think it was well deserved. But in the last year, Docker really improved. So there are now, as I said, two specifications: the OCI runtime spec and the OCI image format spec. And Docker re-architected the whole stack to match the split of these two specifications. You now have a daemon called containerd, and you have an executable called runc. Now, containerd is completely in charge of your image format specification. So this is the guy that pulls the image from the web and installs it locally, basically. It deals with the package. And then it invokes runc, the executable, to run your app. Now, what you want is replace runc with something else. So you can still use a packaging that is very well suited for pretty much everything, and it comes with all the very powerful tools of the Docker ecosystem. But instead of running it using runc, you can run it with something else. Like, for example, stateful.zen, of which I talked about last year, or Kata containers, or runv, or a number of other alternative runtime environments for containers. Okay, so how does it tie together with Virya? It ties together with Virya because Docker is a fantastic tool. People want it in IoT, and we should be able to give Docker to our users in a way that is secure and is easier to do so. Okay, I talked about the problem space as lens, and I'm hoping that all this information I'm going to help you understand the design choices and the ideas that are in Virya. What is Virya? Virya, as I said, is actually a number of things. It's a flexible build system based on containers, meant to solve the first of the problem I talk about in this presentation, the multi-domain build problem. So it's, in fact, what I call it a multi-domain build system, because it's designed around the idea that you're going to build more than one domain at the same time. It's also a set of tools to build an image that has a secure exam-based runtime for containers. So it is meant to solve the second problem by producing an image that runs your containers securely as virtual machines. A turnkey solution, what I say is, when a user uses Virya and produces a final SD card image for an IoT device, once the SD card image is installed, everything should work. It's not like the user needs to go and edit device tree on the host, or do Docker pull, or install other things and do additional configuration. That is the reality of today. No. So what we want is to provide all the configuration tools so that at the end, the produced image is ready to run with everything included. The goals are to support both x86 and ARM, and is mostly targeted at embedded and IoT. And so, of course, you can run it. You can run it anywhere if you like. Okay, I'm going to start to talk about the build now. As I said, it's a multi-domain build system, and by that I mean the idea is that it will allow you to build more than one domain, so .0, other domains like your Android VM, as well as driver domains or any of the core system domains you want to have, all together in parallel, and pull all of these binaries into a single final random image. Each domain is built in its own container, and that is what allows the parallelization of the build and also using different build systems together. So you can have your Android VM being built using the Android build system inside a container, and then alongside an Ubuntu VM using the Ubuntu packaging system is on another container. I'm going to show you a diagram that I hope it helps. So in this picture, all the white squares run as containers. So in this picture again, we have in this example a .0 rootfs based on Alpine Linux running in a container, a .0 kernel built based on Yocto running in another container. This is actually what we're working on now, and shows you already some of the features that having a multi-domain build based on containers give you, because you can have the kernel out of Yocto that has the best infrastructure to build targeted kernels for IoT devices, but then you can have the rootfs coming from a completely different project using Alpine Linux. So this is actually using the Yocto tools to build the kernel, and this is actually using the APK build tools from Alpine Linux to build the rootfs. Then you can have, in this example, a driver domain based on Yocto, and another driver domain based on Alpine Linux. All these container builds run in parallel. They produce a binary output. The format of this binary output can be a bit different. I'm going to tell you in a second. But the point is, the binary output is given to the image builder component. Image builder takes all these binaries and pulls them together into the ready-to-run SD card image. Image builder itself also runs as a container. As I said, it can take different formats of these, let's say, domain binary images. Of course, it can take rootfs, but it can also take a bunch of APKs and install it themselves, Alpine Linux APKs. It can take other formats as well. It can take traditional images from, so you could build completely outside of the system a traditional VM and give it to image builder with the right configuration, and image builder will pull it together into the final image for you. Okay, so we discussed so far that the square boxes here are all containers. Now, what you might not expect is also the round boxes here are also containers. So, okay, except for this one. This is actually an SD card image, all right? So sorry for the confusing diagram style. But these are all containers. Why? For a number of reasons. First of all, this way we have a single abstraction. So everything built as a container produces containers. Containers are given as input as another containers, which finally produce a final image. So it makes actually building the system easier. But there is another reason. Well, if you do everything as containers, it's faster because you don't need to export or import actual files to the file system. It's all handled with overlay FS, which is much faster. But the best of all reasons is because these are containers, and when I say container, what is an APK container? It's a container with a directory and a bunch of APKs in it, and nothing else. What is an image.gz container? It's a container with a kernel binary in it and nothing else, to be clear. So what can you do now if all of these are containers? You can push them to the Docker Hub. So let's suppose that you have this build already done, and you want to change a line in your Yocto kernel. All right, you'll have to rebuild this. But everything else, you can pull it from the Docker Hub. You don't need to rebuild it anymore. So the Docker Hub becomes an automatic cache for your artifacts, for your build artifacts. And it's actually free. So as long as it lasts, let's use it. So yeah, so if you're wondering, you could use the Docker Hub to store your MP3 collection. You store it in a container, you push it to the Docker Hub. It actually works that way. We tried. Right, so what are the features again? Everything built as a container. All the intermediate outputs are containers, so that they are pushed to the Docker Hub and pulled from the Docker Hub automatically. We support cross builds by default, and we use regular cross compilers for the kernel and Zen, but we use QEMU user for the user space components, so that from the inside it looks like a regular native build. What is QEMU user? QEMU user is a binary that is produced when building QEMU that allow you to run a user space C-root environment of a different architecture on top of your regular machine. So you can have an ARM C-root on top of a x86 laptop. If you can have an ARM C-root, then you can have an ARM container on top of your x86 laptop. So it's just as simple as that. You run QEMU user so that you can have our own ARM containers on top of your x86 server machines. It works very well. So for example, the Xen build that on my laptop, the native x86 build takes about between 2 and 5 minutes. Using QEMU user, it takes between 7 and 10. Which, well, of course, it's not going to run on my laptop. It's going to run on Amazon AWS or on Google Cloud, so it's not a big deal. It enables you to use whatever build system you can imagine for any of the components. So we are focusing on Yocto and Alpine Linux because they're the best fit for containers and embedded devices, but you could use really anything you can imagine, as long as you respect the other interfaces and naming convention of the intermediate containers outputs. Yes, I think I mentioned everything about this. The runtime. Okay, the runtime is, well, as you as Zen developers are going to be less maybe impressed with the runtime, but the goal is to produce a regular Zen-based environment that can run traditional VMs, but can also run containers securely using Docker and Stage 1 Zen. So one of the work items we have is support Stage 1 Zen that was developed for Rocket to Docker. And I already have a prototype of that, so it's not a very big amount of work. Other things we want to support is measured boot on ARM as well, which is something new, software updates, and disaggregation. So the idea is that now that we have a powerful multi-domain build environment, it makes it actually easier to disaggregate your system because you can use unikernels, you can use anything you like to build your driver domains and service domain and put them all together into the final image. So we are planning on using an A plus B partitioning system to make updates easier, so that you can, while you're running on Zen and on Zero on partition A, you can pull your updates and install them on partition B and just switch the root when you boot. Okay, so the very, very basic environment that we plan to enable is .0 on Zen with a bunch of containers runs as VMs, and then container VM state on Zen is on 0. Right? We should definitely be able to do this. But once we accomplish this, the next step is to move container VM state on Zen to its own domain manager and take these components out of .0. And then the next step is to add driver domains. And specifically, we are talking about a network driver domain here and a TPM manager at the very least, so that .0 doesn't have to have the network card directly, might not even need network access at all. Okay, so I'm going to tell you about the current status, and then I'm ready to answer all your questions about this project. What the current status is, we have a temporary mailing list because, well, it's not actually an official sub-project yet, so we are looking forward to move to an official and public mailing list. We have GitLab repositories, so we chose GitLab way before the Microsoft acquisition, and the reason for choosing GitLab is that GitLab allows you to disable web pull requests. And as traditional all-site developers, we hate web pull requests. So this way there is no mistake. And when somebody go and try to make a pull request, we don't have to go and say, no, please send emails. So yeah, this is great actually. We're at the early stages of development. So we do have some components already, ready to use, but not the whole system. So we have an SDK. What is an SDK? So especially the other engineer working on this project is very keen on giving to users a reproducible build environment. And he's also keen to enable people with macOS X or Windows laptops. So we produced an SDK image, which is a VirtualBox image, with all the tools you need to run the ViryaOS build. So things like Docker and maybe GCC and so on. Now, the SDK that to me as a Linux user is completely uninteresting, I'll be honest with you. But the SDK is interesting in this context because we use the same concept for Virya to build the SDK. So the SDK itself is built using containers, is built using something like Image Builder to put the image together. So we use the SDK to try out a lot of these concepts. It's been our trial ground. And the SDK is almost complete. We already have a container-driven build, and we have the Yocto kernel build in a container done. What we are working on at the moment is the .0 rootfs based on Alpine Linux build, and Image Builder is not complete also. We are aiming at the moment at August to have these pieces complete, and something actually demoable. Okay. Do you have any questions?
I'll throw out.
There we go.
Why do the SDK as a image, as a VirtualBox image? Why not just do it as a series of containers?
Because
Like native on Mac or something.
Because if you do it that way, you are not certain of the Docker version and the tools version that the user is going to have in. So the idea that you can have a completely fully reproducible output bit per bit.
Right. I mean, I guess in theory you could just take it off of the Docker and Docker get more Docker.
But then you rely on the version of Docker.
Yeah, that'd be your.
Like here, I guess we rely
okay.
on the version of VirtualBox, you might say, but typically there is a less less ties. So the version of Docker is actually very critical for a number of things like the.
Oh, probably because right now there's a bit of change.
There are a lot of changes, like for example, we discussed yesterday the introduction of an Arch environment variable to specify Arch-based build. So the Docker version is very important.
So, follow up, is it Xilinx sponsored, or is this like kind of you?
So I actually started this before we started discussion with you. So Xilinx is very interested, and I cannot really comment on commitment yet.
There's also another party.
Yes, there are other parties there are a lot of parties that are interested. So at the
working
moment,
already on it,
Yeah.
which is the Stefano, right? So in terms of project status, we got all the bits and pieces in place now to have a formal vote about it. So we'll set this up after the summit. We still want to do this a little bit low key, so we're not going to do any announcements until we have something. So within the community and stuff we talk about, but we don't want to have a register story or something which says, which gets before we have stuff ready.
As I quickly mentioned, the idea is to have a launch in August or September, and to have a proper launch. I mean, you don't want all the details to be leaked. Of course, because this is as a project proposal, is a Radium's idea. So if you Google for it, it's going to come up. But there is a difference between having a proposal on a mailing list and actually making noise.
You plan on keeping it on its own mailing list, ViryaOS.
Well, I guess we have one which is based on the previous names. We
Yeah,
have to
we
be
have to
naming
have,
this, stuff
there
like
need to
that.
be public mailing list
Yeah.
as soon as
Well, we could probably open that and add that.
name it, so.
Oh, we have to. Okay, so let's deal with the infrastructure stuff first. So, but if people are interested at this stage, they can just contact Stefano and
Yes.
we can,
We started with a semi-public, meaning that I will have to approve requests mailing list,
Yeah.
and as soon as the project is approved, we're going to move to a public, fully open mailing list.
Yeah. Also, we have to think about because like that list has a. Do you still have the huge
I have
spam issue?
I have more than 5,000 requests at the moment, all of them spam.
Yeah, I have the same on top. Yeah, like 5,000 requests to join a day. So if we remove that, then we're going to be doomed and
So
spam
if
to
you
death.
go and trying to register to their mailing list, I'm likely not going to approve you just because your request will be lost in the 5,000 I get a day, of the
Yeah.
spam.
So,
Yes.
any other questions?
That's okay.
It's for the recording.
Yeah. What is the image size? Whatever you have right,
Right. So we are targeting as small as possible. So I think it's going to be something around in terms of disk image size, not runtime size. Okay. So I think it's going to be something around between maybe 5 and 10 megabytes, less than 20 megabytes, something like that.
now? Okay. One next second question. Sorry. So since this is targeted for embedded, right? So also you need to figure out applications to run on it. So usually each of your driver domains that you mentioned, effectively you will have multiple containers possibly for an application. For example, you showed a car there. It can be a GPS or a MP3 player, whatever it is, right? So is there a way to kind of plug in which application to run, or do you have that already in mind?
So this is where the build system comes in. And actually there are two aspects of that build system that are important. And I'm going to take this opportunity to talk about the second aspect that I haven't really dug into. So the first aspect, as I said, to make that work, is to allow the user to build, alongside everything else, his own application. And I discussed that. The build system is meant for that and designed for that. Okay? Well, to make that work, but also keep in mind that in the GPS example you mentioned, you also need to be able to handle device assignment. So actually, I think the most interesting part of the build system will be able to not just allow the user to build his own app in a container and then pull the output with image builder, but it's also for the user to be able to specify the devices that the VM needs, and for the build system to automatically configure all the Excel config file with the device being assigned, and also edit the device tree so that the device is assigned.
Thank you.
Thank you.
Before to you, I have a quick question. So also this is all designed for embedded. I mean, there's no reason why this couldn't be
No,
used
actually,
in another
so
context, right?
especially on x86 where the environment is very standard. It's reasonable to be able to take one of the x86 output images and run it on your server just to be able to deploy secure containers with Kubernetes. That should be completely doable, and you should be able to enable this. Also, it's not one of the primary goals, but yeah.
But also the build side, I mean, there's no reason why.
The build side, but on x86, especially for the data center, you don't care that much about aside from driver domains, you don't care that much about including user application into the final image. So usually those are deployed dynamically. So this is why, but if somebody wants to do it in the data center, go ahead. It's just it's usually not something that comes up.
So you mentioned SD card image A/B testing as well. So I mean, I guess you're going to have two results: an SD card image with a bootloader and whatnot, and then also just a file system, correct? Or just one file system. So
it was about updates.
yeah, so
the
updates.
idea is to have.
Yeah, and so right.
The idea is to have. So this is going to be 1.0 file system.
Right.
This is going to be another 0.0 file system, and you can switch between the two.
Right. So your SD card image really needs to produce. There's two artifacts: the initial install and then your update image, correct? Which is like a P1 or a P,
Yes,
a new P1.
Yes.
Okay. So that's one of the things you're already targeting.
Yeah.
Is the update image. Okay. So then the bootloader, you mentioned ARM. Have you made any decisions in the image builder what bootloaders you're using and whatnot, or are you?
So we discussed a number of them. I think it's likely that we're going to end up using UEFI because that works well on pretty much everywhere.
Right.
And with device free, so on ARM and ASIC.
So I mean, also as a further thing, I mean, there's a from ELC, there's a number of companies that, I mean, you and I stood in front of a couple of them that are pushing their little, oh, you just give us a system image, we'll handle A/B testing. So I mean, you could also have those upgrade images created so that users can leverage that from
right.
companies.
There
as
are
well.
a bunch of companies that are looking at after the update. I think one is called actually system update, if I can't remember exactly. Yes, so we're planning to use one of those.
Yeah. So I mean, you could reach out to those and
Yeah.
basically say, oh, we support that natively and
Yeah.
whatnot.
All right. Any other questions? Already running. We started late, so I guess we're still reasonably in time. If not, thank you. We will have a sort of related design session sometimes later today. That brings me to the point, because we had a schedule change.